Welcome back to Research Methods. This week we're going to be tackling sampling methods, which can seem like a mundane, normal task at first, but there's a lot to consider with sampling methods, and ethics bleeds right into it. So we're going to go ahead and hop in and figure out why sampling is an incredibly important part of research methodology. So let's start out with some basic definitions. It's really important to have some of these terms down because we will be using them over and over and over and over. So it's good to not only have these definitions memorized, but have them down in such a way that you can be using them flexibly throughout the rest of the course. So real quick, sampling, here's one definition, as the selection of a subset of individuals from within a population to estimate characteristics of the population. And what's a population? Well, the population is the entire statistical group that you're trying to research. And that's a lot of big words. So really what I'm talking about is I want you to think of like an Amazon warehouse being an entire population of people you want to research, right? That happens a lot with industrial organizational psychologists. They want to learn more about one population, the entire warehouse. So you need to sample from within that warehouse, and you need to get a sample size that represents the whole warehouse pretty well. You could research and survey everyone in the warehouse, but now you're talking about 1,500 employees for the average large facility, where Amazon facility, and that takes a lot of time and money and effort, especially when all you need is roughly about 300 people to represent the whole 1,500 people in the warehouse. So sampling is you're going to take a small sample of that whole warehouse so that that sample can tell you about everything you know going on in the warehouse. So sampling, population. Samples are a small section of that population. Usually the next question is, well, how many people do I need to have to represent the whole population? Well, that differs a lot depending on a couple different variables, right? I mean, if we're an Amazon warehouse and we're only trying, and the population is 1,500, that's a pretty tight-knit group. We know what we're looking at, and we really can build walls around what we're looking at, what we expect. But if I'm looking at a population of like a city, right? Now we're getting into tens of thousands of people. If I want to know more about what's going on inside that city, my sample needs to be both larger and more diverse than just a few people here and there. So size is one thing, and the variability of that population. So sometimes people who worked at Amazon warehouses, they can sometimes all come from the same neighborhood and things like that. But when you get out to city scale, you can almost guarantee that you're going to have pockets of people who are very different from one another culturally, racially, and so on and so on. So depending on how variable the group is, depending on the size of the population and the variability of that population, that changes how much sample you'll need. Other things that play a part in that, are you doing qualitative research? Are you doing quantitative research? Are you asking how tall people are? Are you asking about subconscious biases? That complication of variables really lays into how many people you need to fairly represent the whole population. Now, obviously, every researcher wants the largest sample size possible, right? The bigger the sample, the easier it is to do stats later on, and the cleaner those statistical conclusions can be for you. So everyone wants the biggest sample size possible. And of course, who wouldn't? But, right, and you'll see right there on the slide, but how far will your funding let you go, right? Research is not a free task. Research is not a free task. And for lots of reasons, it's not a free task. One, the researcher typically wants to get paid for their work and eat food at later on. So you got to pay the researchers, right? But there's other reasons that make research very expensive, and one of those things is incentive. Sometimes you want to give your participants like a little gift card, a thank you for working with me on my research, 20 bucks. Now, 20 bucks ain't too bad. It's not too expensive, but now if we blow 20 bucks out times 300 participants, we get into some numbers and very expensive numbers very quickly. So how much money, how much funding are you allowed to spend on this sample size? For incentive, for paying the researcher, and also time. Timelines are really important. Some research questions are time sensitive, so you can't just spend years and years and years collecting a sample size and making it as large as possible, because your research question will eventually become outdated, or because different age groups think of things differently, you might get age as a extraneous variable in your research question. So how much time do you want to put into getting a sample size, and how much money are you willing to put into getting a large sample size, are two major limiters on why we stop at certain sample sizes. There's other helpful tools for defining just how big your sample size ought to be. I posted a sample size calculator. It's a website that I use a lot, and if you scroll down beneath the calculator, it actually has a lot of statistical descriptions and definitions. So if you want to do it on your own at some point, you can, or you just use the calculator. But another term that is very helpful is sample framing, right? You can't just go into a population and start pulling people left and right. You need to have a methodological approach. You need to have more method and more reason to what you're doing. So sample framing is one way to do that. And it's really simple. A frame is essentially just a list of the whole population. And from that list, you can work on how you're going to sample next. So things to consider before sampling is how much time and money do you have? How much sample size do you need? And can you get your sample framed before you get started? These are great ways to start any research project. So now you've gotten everything set up, you've gotten your ideas of what you need to be doing. Now the question is, well, what method of sampling do I use? What method or approach of sampling will best fit my research design? And that's where we're going to start getting into the nitty-gritty of sampling. So there's two major categories, and each category has little sub options underneath each one. So we have probability, we have non-probability. And each one of those has at least 4 different approaches that we'll be talking about today. Probability, this is when participants are chosen according to the rules and practice of probability. This is the one where we are getting as random and unbiased as possible. We're getting as objective as possible, which science loves. If you want to talk about generalizing your conclusions later on, you need to be as rigid, getting your own bias out so that you can apply these approaches later on. These are typically preferred because of the stronger generalizability and the objective nature, but that doesn't always work out for every research design. Sometimes the participants you're trying to study are just hard to get to for one or a myriad of reasons. So if probability doesn't work, you also have non-probability, and this is where participants are selected kind of based on what the researcher wants to their research to look like. Now, you should hear me say that and go, oh, we shouldn't be putting our own opinions and likes into the research. And I understand that, and that's a really good reaction to have. You should hold on to that. But not every research design allows for perfect probability. One quick example of that is when I was working at the public health department. We wanted to know more about a certain population of immigrants who had come in, but through generations, they have not technically become legal citizens of the American society. That United States citizenship hasn't been granted to them for one reason or another, but they've been here in our city long enough that we want to know about how best to serve their health needs, especially during COVID at the time. But if we just kind of put out there, hey, we're looking for participants, they're probably not going to show up because they are afraid of working with government entities, because they're afraid of being deported. So a non-probabilistic approach might reach that group a lot more efficiently, even though it's not as probabilistic as we want it to be in good science. So there's reasons for non-probability, even though it sounds like the lesser option. There's good reasons for it sometimes. All right, let's quick talk through some of the probability sampling options that we got. Right, so with probability sampling, remember you're just trying to stick to that rule, that law of probability, stay as unbiased and objective as possible. So here are 4 ways to do that. That first one is simple random. So remember, you have your sampling frame, you have your list of names at the Amazon warehouse from earlier. A simple random approach would seriously be to cut up all those names, throw them into a jar, and randomly pull names. Like a lottery chance. There's also some Excel spreadsheets that will just do a randomizer for you, and it'll select random names out of a list or random options out of a list. There's also online wheel spinners. But simple random is exactly that, purely random choosing. Systematic random, very similar, but this time we're using very specific intervals or very specific distances to create that randomness. A couple ways that this can look is every 3rd employee that clocks in at Amazon that day, we'll survey them. Or every other employee at a given workstation. So if we go to workstation 1, we'll go this person, but not this one. This person, not this one. This person, not this person. And then we'll move to workstation 2 and do the same thing. Workstation 3, same thing. And that interval, that little gap is always the same systematically, but still kind of random because we don't know who's going to be standing where that day. The next one we have, the next 2 are actually pretty well related. They're both strata. We're going to talk a little bit about what that means, that word strata or stratification. So let's talk about stratified sample. This is when the population is stratified, and stratified means to divide into subgroups, right? So when a population is divided into subgroups, and then the participants are randomly selected from those subgroups, right? So a random collection from some of the locals and some of the commuters at this warehouse. A random collection from some of the night shift workers and some of the day shift workers at this warehouse. That would be a stratified sample because the strata would be that division, right? So the population being the whole Amazon warehouse. Some of the stratification, some of the strata might be locals and versus commuters, night shift versus day shift. And there's lots of different ways you can stratify. Stratify is in the probability sampling, but technically it does require a little bit of research or opinion or specificity. And then the last one we have for probability sampling is cluster sample. So again, we're stratifying the population. Population is stratified, divided into subgroups, and then at random, the entire subgroup is selected. At random, the entire subgroup is selected. Now, there is like this tendency to think of cluster more as like natural clusters and not researcher divisions. Stratified samples are thought of more as like the researchers decided we're going to separate locals and commuters. But cluster sample is, we've noticed that this group tends to work together, this clique tends to work together, and they cluster together more often. And that would be, well, let's go test that entire cluster and see what happens. Also, in that situation, you can think of different workstations in the Amazon warehouse, and that entire workstation being sampled for the participation of a study. So we talked about probability sampling styles. Now we're going to talk about non-probability sampling styles. And we've got 4 of those too. We have convenience, purposive, snowball, and quota. Convenience sampling, that's when participants are chosen simply because they're easy to access. You can think about that one guy outside of a supermarket with a clipboard, and he's taking surveys of whoever will answer them. That's convenience sampling. That's convenience sampling. Purposive sampling, this is when participants are selected based on a specific criteria, right? So if we go back to that health department example, we specifically chose participants who would be those immigrants who did not have citizenship yet, and those are specifically chosen, and those are the people we want to study and know more about. But it's not just like some form of racial discrimination thing. It's any group of participants who are fitting a specific criteria. So you can also think of like surveying all of the employees who are at the same car crash that morning, or surveying all of the employees um, who do happen to be of a similar descent, a racial descent, because you're trying to get their ideas about something or their experience at that job. So that'd be purposive sampling, trying to fit that criteria. That one's really nice for quick research, but it's not always the best for having a strong representation of the whole population. Remember. So the next one being snowball sampling. Participants are chosen, often purposefully, and then asked to recruit other participants, right? And this is the one that we ended up doing with the immigrants at that health department situation. If we could get to talking to 2 or 3 people without that citizenship and have them fill out a survey, then we just gave them the survey and said, can you bring this home with you and give it to the rest of your family who works? And then give them a copy to give to their coworkers, and so on, so on, so on. Hopefully, this helped us reach an entire population group who was afraid to come to us, so we just asked them to go to each other. And that was the really big strength of snowball sampling. The weakness of snowball sampling is you really don't know who's getting the survey, and you don't know if they're being chosen very broadly and in an unbiased way themselves. You might be getting a whole bunch of people who think like your first person and not just a whole bunch of people that you're trying to target. So it's a risk, but it can be helpful when it works. And then finally, we have quota sample. Quota sample is very interesting. It's in your think about dividing your population into different strata, and then looking at the percentages of each of those strata, and then you're trying to make your sample look like that. So, for example, I live in a small Kentucky town, and in this small Kentucky town, we have, I think, 89% white people, and about 11% is mixed somewhere between Hispanic and Ukrainian populations, right? So when I take my quota sample of my population for my small town, I might try to make sure that my end sample is 89% white and 11% split between Hispanic and Ukrainian populations. This way, I'm hoping that my sample reflects the entire population of the city or the small town. Now, this works really, really well in some situations, and in other situations, not so much, because quota sampling also tends to turn into convenience sampling, because after you do those divisions and percentages, it tends to be the first couple people who show up, right? So instead of getting 89% white people, I don't know for sure that the 89% of the white people I got represent the entire population of white people in that town, right? And the same thing goes for like that 11% between Ukrainian and Hispanic populations. I don't know if the few members I got to actually represent the entire Ukrainian or Hispanic populations, right? So that one also has a risk of like the sample represents the whole, but each pieces of the sample represent those pieces of the population very well? So to sum up the 2 different major ways of doing sampling, we have probability and non-probability, and each has their strengths. Probability is probably the one that researchers like the most. It grants equal opportunity to all participants to represent the whole population well. Because the selection is random, results tend to be unbiased, and objective methods mean objective conclusions that can be generalized very well. You can actually test a hypothesis this way and get support or a lack of support for every hypothesis. Non-probability, this is more weighted for like representation, or if you're having a hard time getting to selective specific populations. But because it's not probabilistic, because it's not objective, you can't really test a hypothesis the same way you can test a hypothesis with probability. So obviously there's a preference towards probability in these sampling methods, but that's not always how it ends. That's not always how it ends. So let's move on to the next step of sampling. Now that we've learned a lot about some of the different tools we have available to us, probability and non-probability, what do we do with them? What other things should we consider as we move into sampling? All right, every sampling process, every research project has its challenges, and the more you understand about those challenges, the better you are prepared to then deal with them. So let's talk about those for a little bit. Probably the biggest challenge any and every researcher will ever have is non-response. You can ask thousands of people to respond to your survey, and you might get tens, 10, 20, 30. And it is so hard to know who is going to respond and who is not going to respond ahead of time. That non-response issue is very difficult to overcome. Now, in work settings, it's easily overcome because the manager simply says, everyone's taken this survey, and then you move on, right? And then you move on. But that's not always the case for every single research design, especially in research designs around children in developmental situations. Developmental psychologists have a lot of issue with getting parents with their kids or guardians with their kids to show up, to say yes to this research. And there are some ways around it. There are some ways around it. You can remind participants that, hey, this is what we're studying, this is why it's important, kind of make that argument. You can do follow-up reminders on people who said, I might be interested, and then you send them the info once, but then they don't respond. So you send them it again and again and again. Those follow-ups might be helpful. But what I've seen in my experience and a few other experiences, that it tends to be incentives that get people to show up and participate in research. Um, I'm kind of curious if that's true in every culture in every country, but right now I know it's pretty true of the different researchers I've been around for the last couple of years, that it tends to be offering incentives, offering a gift card, offering a dinner at a restaurant, like a gift card to a dinner at a restaurant, offering Visa card money, offering um, a variety of coupons, who knows, but offering incentives tends to be the one that gets people to show up. Now, with offering incentives, you do also have to keep in mind that every time you offer an incentive, that there's ethics questions involved. You can't just offer every participant a $10,000. That's kind of unfair to different lower socioeconomic status participants. They might be desperate for that kind of money. And people who are very, very rich and higher economic statuses might view that as kind of not true or not worth their time. So you might end up actually still with a sampling bias in the first place through offering incentives, and might accidentally do some harm on those who might be dependent on money too. So incentives is like this double-edged sword where it could work for you really well or against you really well, depending on the ethics of the situation you're in. Another major challenge is attrition. Life happens to us all, and sometimes life goes through unplanned barriers and boundaries and has all these stops and turns and twists, and that's not just true for the researcher, it's true for every single participant who comes to your research. Say you're studying that Amazon warehouse, 1,500 people are there, you finally have your 300 participants for your study, and then 15 of them get either sick, or a babysitter gets sick and they have to go take care of their kids, or the cars break down, and now you've lost at least 15 right off the bat, and then who knows how many are going to stick around to the end of the study. This is what attrition is. Attrition is, for one reason or another, participants start but cannot finish the research. There's lots of things that you can do to help with this. Maintaining good communication. Hey, what's going on? Is there something we can wait for? Is there something I can help with? Things like that. Um, Another major one that helps with attrition is making the research process as easy and fast as possible. If you have participants show up for a 5-minute survey, you're less likely to have an attrition problem. If you want participants to show up for a 10-year longitudinal survey, right? So they take the same survey every week for 10 years, you're much more likely to have a lot more people fall out for different reasons. So attrition is something that sometimes you just have to deal with if you're doing a longitudinal study. But for the most part, if you can keep your research study brief and as fast as you can, you tend to override this pretty easily. But one thing that is always helpful is having a backup list of participants where you kind of over ask. I only need 300 people. I'm going to ask 600 people, right? And the goal there is if 20 or 30 or 40 or even 100 of my original group can't make it, I have this backup list of people who said yes, but I didn't need them, but now I do need them. So that backup list there can be very helpful. There's 2 asterisks there. Something to note about backup lists. You have to go through all the same ethical considerations for them as you would your primary participant group, right? Your primary sampling group. So as helpful as that backup list can sound, you have to make sure that you're staying in good communication with them. You have to make sure that you're considering all of the ethical implications for them, and it can sometimes be a lot more work too. Finally, we come to sampling bias. What happens when a researcher lets their preconceived notions, their preconceived expectations, their schema, their stereotypes get into how they're choosing who shows up for the research, right? It's one thing to have bias in your research design. It's another one to have it in your sampling. Who do you allow to show up and take your test is a big part of sampling bias. We're going to talk about more of that in a second, but some quick and easy ways to fight against sampling bias is use probability methods whenever possible. You can't accidentally let your racial prejudice get in the way if you don't use bias, like if you use probability instead of your own expectations. If the researcher is using their own specificity or criteria, we might have some issues, right? But if we're just using probability, probability gets a lot of that bias out of the way. If you must choose non-probability sampling methods, there's a lot of ways you can creatively mix probability back into the sampling design, right? So you might start with recruiting participants through convenience, but then after you have your participant pool through convenience, maybe then you do a random selection, right? So you over ask again. I need 1,000 people. You only need 500 really. But say you get 1,000 people through convenience sampling, and then you go through half of them and say, I need you, I don't need you, I need you, I don't need you. And now you've kind of added some probability back into your non-probability sampling, and that helps a lot. That helps a lot. But you got to get really creative with that one. You got to get really creative. It takes a lot of work. And then one thing not to overlook, ask your peers. Most researchers are working at an institution or working at a business. Ask your peers what they think. Ask someone who disagrees with you on most things what they think could improve your sampling. Also, if you're at an institution, go ask your IRB. It's their job to make sure all things are ethically considered, but they're also typically pretty well experienced people in other means of research too. So these are the 3 biggest challenges that come up to when it comes up to sampling. And there are some approaches that are shown here on the slide, but now we're going to zoom in on why sampling bias is such a big deal. So sampling bias is got a couple of different specific avenues that it can show up. One is the selection or exclusion bias, right? Through this is what happens when some members of a population are more likely to show up and be sampled or less likely to show up and be sampled because of something in your design or in your sampling, right? So if you have sampling criteria, you might end up over-representing a group, another associated group, um, and not know it, or underrepresenting another associated group and not know it. For example, you might be sampling a high economic status group, but there's another criteria that connects itself to that one that you may not be aware of, and you might be over-representing that criteria without being aware of it. Another big reason that selection or exclusion can happen is simply accessibility, right? If you want to ask questions about parenting styles, you might have a really good shot showing up to like the public library and polling people there, but then you kind of accidentally leave out a whole bunch of people who don't have cars to get to the library. And you inadvertently cause a selection bias or an exclusion bias by simply not letting your research have the same accessibility to all subgroups within a population. Another two more things that kind of get in the way of sampling bias, the way these show up, is self-selection and availability. For the self-selection one, I want you to think of that one kid in class or that one classmate who's always like, I have an answer. I want to be a part of this. I want to do this. And that's great. That's great. Researchers want participation. We do. But that doesn't always mean you get the whole population represented. If I'm talking about a whole city and I need 100 participants, I might get 100 people who are all that same kind of behavioral personality type. Oh, I want to do this. And because I get 100 of those people, I don't really get a good representation of the rest of the city. And that self-selection, although very exciting for a researcher, can actually lead to more problems about generalizing your conclusions. And then lastly, we're going to talk about availability. This is essentially when convenient sampling is used when you could have used something else. When someone wants to sample quickly, this happens a lot with journals, where someone wants to publish quickly. So what they do is they turn out of their office and survey as many students as they can, and then they come back um, and they publish these results as if it is like this big probability design. Really, it was just a convenient sampling issue that got pawned off. So sampling bias is something that is actually so common that we actually have an acronym for this phenomenon that we're seeing in a lot of Western research right now. It's called the weird problem. And I think it was originally discovered a little bit before 2010, but believe it or not, this is still a problem today in 2025, is the most recent article I've read about the weird problem. Well, what's the weird problem? It's a sampling bias problem. Weird stands for Western, educated, industrialized, rich, and democratic. Either a society or a subpopulation. And when these groups show up, they tend to be the first ones tested or researched or sampled. And then psychology, especially psychology, samples from these places and then generalizes it out to the whole world or to the whole country. And that's not a really fair representation of what we're seeing in the whole country, because we're only really zooming in on these weird research participants. And here's some other stats over here on the side that came from Heinrich back in 2010, but these have only been evaluated in 2025 to find and found still pretty true. 96% of all psychological samples come from countries with only 12% of the world's population, right? So psychology is putting out all of this research, but it's still only representing about 12% of the planet. 68% of the subjects in these studies come from the United States and are majority undergrad students. It is so common for a larger institution to have a professor who wants to do research. Well, what's a good place to get where's a good place to get research participants from? My Psych 101 class. I can just make it extra credit and they'll take the survey and I've got like 30, 40, 50 more participants right there. And I can do that every semester. And this temptation to continually use just undergraduate students has found this problem, this weird problem, where a lot of these undergrad students kind of get stuck in this weird status and they don't really represent the larger society, even the larger institution. Research indicates that participants from weird societies are among the least representative populations when generalizing for the whole world. What does that mean? It means when we're talking about weird participants, weird, not weird bad, but weird in the sense of Western educated, industrialized, rich, and democratic. When we talk about weird participants and all the studies that come from weird participants, we find that these participants are probably the least likely to represent the rest of the planet for a variety of reasons. So sampling bias is not just some problem to overlook. It's a problem that is in every institution across America right now, and hopefully being dealt with by IRBs and professionals alike. So it's something I want you guys to be looking out for too, and keep in the back of your head while we continue with our class. How are you avoiding the weird problem? How are you intentionally trying to make sure your sample is a true representation of the population? So with this weird problem, with this sampling bias problem, why does it matter so much? It matters because of two major reasons: validity and bad science. So validity has this internal and external sides to it. We'll talk more about that throughout the semester, and we have already talked about it a few times. But remember, internal validity is the accuracy and ability of a design to represent the real phenomenon being observed or manipulated. External validity is the extent to which I can generalize my conclusions to the rest of the, well, I say the world, but it could be different populations, different settings, context, times. So if I'm studying an Amazon warehouse, external validity is the question of how many other Amazon warehouses are like this. And internal validity is the, okay, here's my research question. Does my measurement actually tell me about my research question, or does it tell me something different, right? And if you have bad sampling, both of these are under threat. All right, bad sampling could make sure that your research question, even if you have an okay research method or measurement, it can be really affected by a bad sample. And now you're not even sure what phenomenon you are studying. Or the external validity. If I do a bad sampling job at my Amazon warehouse, I'm not sure how many other Amazon warehouses I can stretch these conclusions out to. But more than just that, it could be bad science, right? Am I talking about a phenomenon that I found here, and that's a phenomenon that's in lots of other places? That's typically how we sell our articles and journals, right? Or because of bad sampling, is this really just a phenomenon here where I sampled at? But this also can lead to misleading conclusions. Hey, I found out that everyone is 6 foot tall. No, that's not true at all. And because it's not true, you might end up saying something about a population that could be quite harmful in the long run. And the last thing that is really important, and this is really, really why sampling has to be done correctly, is because bad science is a self-perpetuating thing. If I publish 3 or 4 articles that all have bad samples and come to these misleading conclusions because of the bad samples, well, the next person might read my articles and go, huh, I'm interested in that too. I'm going to use his work as a basis for mine, but now we're both just studying bad stuff, you know? And now we're both just studying bad stuff. So bad research is self-perpetuating and misleading, and that misleading conclusion can really cause harm in populations throughout time. That's all I've got for sampling. We will be overlaying sampling and ethics very soon, and I can't wait to see you guys again. Bye.